So page 376 in your Math Makes Sense textbook, Pearson Math Makes Sense textbook, you have a study guide. And at the end of the chapter is really, really good idea to study the study guide. I do have a video as well on mrmathwell.com that you'll be able to look at. Okay, so once again, on mrmathwell.com, go to your courses page, Math 9. Scroll down, here's all the Chapter 7 videos. And this is the review video that I made a little while ago. And so what I do is I kind of go through all of the highlights, all of the points of the chapter. And I think that I do some questions from the review as well. So I kind of go over some of the important points, and there will be clippings from the textbook for you. Let me just see here. So for example, right here, okay, so I do some of the questions. So for each sort of section, I do some of the questions from the review. So I do some of your homework assignments for you in this video. So while you're studying for the test, I would encourage you to watch this video, the Chapter 7 Similarity and Symmetry Transformations Review. Okay. The other thing that's important for you to know is the study guide. And as you go through this, this is the kind of stuff that you can put on your cue card. All right. And again, there's talks about scale diagrams, scale factors, similar polygons, the ratios of their sides right here. Remember that? Okay. And so on. And what about similar triangles? We did a whole section on similar triangles and how to solve for unknown parts and things like that. Then talks about line symmetry and rotational symmetry. So this study guide, very good for you to study for your test using this guide as well. Okay? Make sure you make your cue card. You're allowed a cue card for this test. So make your cue card, and you can make it from this if you want. Any questions about the chapter review or studying for the test? Any questions about that? All right. All right, so here's the page that I made the video from, and what I'd like to do is just to, you know what, maybe I'll do some, I won't go over this again because this is already in a previous video, but some of the questions from your review assignment I'll do with you, okay? All right, so here's number 4 in your review. It talks about scale diagram, scale factor. Let's take a look at this. Here's a scale diagram of a ramp. The height of the ramp is 1.8 meters. So in your notebook when you're doing this, I would sketch this ramp, just a rough sketch, and I would label it. The height of the ramp is 1.8 meters. So it looks like 1.8 meters should go here. That's the height from the ground to the top of the ramp. Everybody okay with that? Measure the lengths on the scale diagram. What is the length of the ramp? So what is the actual length of the ramp? If this is 1.8, what is this? Okay. So what we have to consider here is the actual larger ramp, and I'm going to make a larger triangle that's somewhat the same shape. I'm trying to do my best to make it the same shape. So if this was the actual ramp, and this was actually 1.8 meters, I want to know what this is. What your job is to find out what this smaller triangle is, and then set up a proportion. So how many centimeters is the height of this ramp? Right? And how many centimeters is the length of the ramp in the diagram? So you're going to have to set up a ratio to find the missing side. Okay? So with a ruler, you're going to have to measure. Now let's say this is h centimeters and this is r for ramp centimeters. Okay? There's 2 different ways that you could set up this the answer to this question. 2 different ways. In the textbook, what they do is they teach you to find the corresponding sides of both, situations. So here's r and here's the unknown, right? So you're going to measure r. So you're going to have r over the unknown quantity equals, and we go back to the same diagram first, h over 1.8. So whatever h centimeters is over 1.8. And because these are going to be actual measured numbers, you have 3 numbers and you have 1 unknown. And then you need to solve for that, right? Now how you do that, do you remember you cross multiply? Okay, so you can cross the equal sign from bottom to top, and then that goes away over there. and you can also cross multiply here. And now you have, you want to divide the h off so the h can go basically back down here. Okay, so this is how you can cross multiply and divide. Everything can go across the equal sign from the bottom to the top, from the top to the bottom. Okay, so you end up with question mark, because this h is going to be gone, it's down here now, equals 1.8 times r, the measured ramp length of your diagram, divided by h, the measured height of your diagram. And that's going to be your answer. Also, another way to do that, and this is another way that I mentioned in the lesson that jumps out at me. This is the way I like to do this stuff. I don't know why this seems a bit easier to me in a lot of cases. So you can choose which one you like better. But what you also can do, because of the nature of equality here, you could go something like this. R over h. You could go r over h equals, again, corresponding side first, question mark over 1.8. That is equally as valid a proportion to set up. Why? Because look at, this one's a little less work actually. All you need to do is multiply both sides by 1.8, so it comes up here. And guess what? This is now exactly the same as we got here with a little less work. So sometimes a little less jumping around, you can get your unknown value pretty easily. So take the diagram length over another diagram length equals actual, length over actual length, or you can do corresponding sides of both triangles. Either way is okay. And I don't want to confuse you. I think you understand this well enough now that you understand that, hey, as long as I'm consistent with which ones I put on top, I can have an equality a couple different ways. Okay? So yes, you have to have a ruler. You should have your own ruler. If you don't have a ruler, I have rulers up here you can borrow. But you need to measure as accurately as possible the length of the ramp and the height of the ramp and use those numbers in your ratio. Okay? Does that help about number 4 there? Yep, probably onto a different question already. Okay, good. Okay, any other questions from the reviews you'd like me to tackle? So for 3A, this is what I want you to see here. Let me just clip this out. Okay, give me a second. I think that your scale factor for A was maybe a little off there. Okay, so I'm going to tuck this question right here in my review notes. So a full-size pool table is these dimensions. Okay, the model are these dimensions. So these dimensions are smaller. So the model is smaller. Scale factor should not be greater than 1. It should be less than 1. So how do we figure that out? Well, this is the larger side. So it's a rectangle, a pool table, right? So we've got 270 and 138. The model is smaller than that. So it's 180 as the long side and 92. So the scale factor, if you remember, is the length, okay, of the model on top divided by the length of original. Is that correct? Okay. So then the scale factor, you can take any two of these, as long as they're the corresponding parts, and divide them. So we got to go 180 divided by 270. Okay, and that to me looks like 2/3, 2 over 3, 2/3, or 0.0 or 0.667 or whatever. Okay, 2/3. So now a standardized, so for B then, so this is scale factor is 2/3. For B, a standard size pool cue is about 144 centimeters long. What's the length of the model? So you got to go, let's take a look at this. The scale factor equals model over original. And I actually want to find the model, so I have cross multiply. I do scale factor times the original equals the model length. And it's just very straightforward like that. So 2/3 times 144 equals my model length. So that's what you need to figure out. So 144 times 2 divided by 3 should be your answer there, okay? All right, any questions about 3 on the review? So back to number 4, I had a question about the units here. So notice this, and I didn't really highlight this at all, but I will now, that in the actual ramp, the height is in meters, okay? And the measurements, we're going to measure in either centimeters or millimeters, whatever you decide, because it's a small diagram in your textbook. So as long as, listen very carefully, this can be confusing unless you listen very carefully. As long as in the same diagram you have the same units, then whatever you solve for in the other diagram, so this one, will have the same units as this. So you see, this is also going to be meters. Mathematically, okay, if you have, I mean, you don't have to have the units all the same, but ideally, you would have all the units the same. But sometimes when you're talking about a little diagram, a little model, and a huge, big actual object, those units are not the same. But if in your diagram, all the units are consistent, they're all centimeters or all millimeters, and then in the real life thing, that's consistent as well, like all the measurements are meters or kilometers or something like that, then the units don't matter, as long as it's consistent within the diagrams. So it's okay to have R over H, let's say, because these are both centimeters. You see that? So when you divide these, those centimeters, they're like gone. It's like 1 over 1, so it doesn't matter. Over here, this is going to be question mark in meters over 1.8 meters. So those will be gone too, but you see, you have to be able to cancel them out, so they should be the same. Okay? So I had a question about the units, and again, as long as you're consistent. Now the other method where you go R over question mark, those are different units, right? But still, R over question mark in meters, but still you're actually still okay because H over 1.8. So that's centimeters and this is meters. Because all the units will cancel out anyways. It'll be fine. This is the same as this over here. So you can basically divide them out from both sides of the equation. So it doesn't matter. The problem you get into, and this is the bottom line, the problem you get into is doing this. If one of these measurements, let's say, is in millimeters, and this in the same diagram is in centimeters, and this is in meters, then that's an inconsistency. So you can't have 3 different units. You can only have a maximum of 2. Okay? So try and be consistent in your diagrams. So this would have to be centimeters, or both of them would have to be millimeters. Then you're okay. Question? Yeah, so if you wanted to do the scale factor as well, you could do that. So this in centimeters, I think it's 0.9 centimeters, is that right? Yeah. The height here in your actual diagram? Okay. Yeah. So you could find the scale factor first. That's kind of the third way to do it. You could go model is 0.9 divided by, now here's the thing though, with a scale factor you should have the same units. So you're going to have to convert 1.8 meters, okay, into 180 centimeters. You should do that. So yes, you can find scale factors, but these, you have to make sure these are in the same units. Okay? Yeah. So what's that going to be? 1 over... 1 over, what's that? 1 over 200? 1 over 200? Something like that. Model over... Give me a second. So that's going from original, which is the actual object, to the model that we're measuring. So 180 centimeters times 2 times 1 over 200 should be 0.9. Is that right? That's let's check my mental math here. Actually, let's just see. So on, where are we? On clear, 0.9 divided by 180 is 0.005, yeah, which should be 1 over 200, I think. 1 divided by 200. Okay, so that's the scale factor. So that means that, question mark times the scale factor would equal R. All right, and what did you guys measure R to be in your diagram? 5 some say 5.5, some say 5.6. Is it 5? More people said 5.5, I think. Okay, let's go 5.5. So how do we figure this one out? I need to know this. The scale factor is 0.005. How do I get the question mark here, the unknown by itself, this method? What do I have to do? I have an unknown times 0.005 equals 5.5. How do I figure out what this is? Shout it out. I divide. Yeah, what do I divide? I divide both sides by this number because it's multiplied by this. I want to get rid of this over here, so I divide it. And I have to divide both sides of the equation by that. Yep, so question mark here, the actual 5.5 divided by, and when you divide by a super small number, you actually get a really large number. So 5.5 divided by 0.005 is 1100. So that's 1100 centimeters or 11 meters. Did you get that for an answer? The back of the book says 10.4. Okay, well then some measurements are off according to the back of the book then.
It says
About 10.4. Well, if the numbers you guys gave me from the measurements here say 11. So maybe do I have to measure it accurately myself? So I would say that your measurement, there was a discrepancy between 5.5 and 5.6. That's probably because I think the best guess would be right in between the two. So this should be 5.55, which that makes it bigger, not smaller. But that doesn't get us to 10.4 for sure. So 5.55 divided by 0.005 gets us to 1110. So 11.1. So I'm not sure how the back of the book got 10.4. If you got 11 or 11.4 or whatever, 0.1, whatever, that's good. Because this one is 0.9. It looks pretty close. Yeah, that's about as accurate as I can get it there. Okay, any other questions from your review?